Welcome to quiz number 1. So this is our first quiz. It's quiz on chapter 1. Now, as we begin these quizzes, let me be straight ahead with you. You're not going to like these quizzes very much. And the reason you're not going to like them is because they are not going to give you any feedback until you've entered every answer. So as you look through this quiz, there's question 1, 2, 3, and on it goes all the way to, wait, how many is it? 14 questions. You have to enter every answer and you get no feedback. It's not like homework. It's a quiz, which means you have to put in all the answers. So enter all answers first, then the whole thing is graded. So the whole thing will be graded after you enter all the answers. And I know that's painful, and you're going to feel like, I wish it would just tell me right or wrong for each question. That'd be better. Well, yes and no. The reason I'm doing this on purpose for your good. My desire is to help you in every way I can to learn the material successfully so that you pass those tests and accomplish your college goals, this math requirement, and get on with your life. I've noticed that when I only give homework and students can redo each question right there and then, that they don't learn it well. Instead, what they do is they just keep clicking on the buttons and they watch the video and they just change until they get that one right and then they move on. They don't learn as much. And they also fool themselves. They say to themselves, oh, I've got it. I got all the homework done. I got it. Well, no, you had to fool around with each homework question. This quizzes will help tell you the truth. A little more truth will come into your life, which we all need, to tell you what you really know and really don't know. Because it's getting you ready for the exam. On the exam, you won't be able to get feedback immediately with every question and then change your answer to a new answer, right? So that's how the quizzes are. The quizzes are like that, and they'll tell you the truth about what you really know. You have to put in every answer, and then the whole thing will be graded. Now, I want to help you as well, so you can retake the quiz infinite times, but you have to redo the whole thing. So it's kind of painful. So you may retake the quiz infinite times, but the whole quiz each time, and it's going to change the problems. New problems. It's going to randomly change the problems. Same type of problems, but it's going to change them. Now, a lot of people will balk at this, and they'll just go, oh my goodness, I don't got time for this. Well, I'm trying to be straight up with you. To learn math takes time. It simply takes time. So everything you need is here. I'm making these videos to show you how to do the problems. You can redo this thing infinite times, but yes, it will take time. You have to redo the entire quiz if you want to fix a problem or two. You have to redo the whole thing. You can't just go back and fix individual problems. You have to redo the entire quiz, and then it's going to give you new problems, but you'll learn a lot in doing that, and you'll get ready for the exam. So there we go. That's the way the quizzes are going to be all semester long. Here we go. Question number 1. Now, you might not have this exact same question, but something similar. It says, determine if the following is an example of descriptive or inferential statistics. Do you know what those are? Descriptive, it describes something. That's pretty predictable. Oops, I'm not doing that too well. Describes. It describes something. Inferential, an inference, it helps, well, let's do this. Not helps, it makes a decision. An inference is a logical decision. It makes a decision. So an example of an inferential statistics would be if a doctor decides that a new cancer treatment is better than the old based on statistical evidence. So that would be an inferential. The doctor makes an inference, a decision, based on statistical evidence. If the evidence is strong that the new cancer treatment is better than the old, that's inferential statistics. Descriptive statistics would be like your GPA, your height, your shoe size, your age. Those are just things that describe you. So, all right, so let's take a look at the question. 85 randomly selected 50-year-old Americans were asked how much money they had saved for their retirement. The average for these respondents was $25,000. The minimum was 0, and the max was $1,200,000. So what about that? Is this inferential or descriptive statistics? This is descriptive. They're just describing, right? They didn't make a decision. They didn't say statistical evidence means we're going to do this or do that. They just described something. That's descriptive statistics. Question 2. 60 adults, let me write a number there, with gum disease were asked the number of times per week they used to floss before their diagnoses. The results are shown. Now, it's incomplete. What do they want? What percent of adults floss 7 times a week? Well, here's the 7 times per week, right? Flossing per week. So this is helping you get used to reading data tables, which is an important part of our course. So 7 times per week. Frequency, what does that mean? That means how many people. Frequency is how frequently the answer given was 7. How frequently did people say, I floss 7 times a week? Well, 1 person out of 60 said that. What percent? Remember, percent is always part over total. That's what percentage is. It's what part of something. So 1 person out of 60. 1 person out of 60 total. Out of these 60 total people that they asked about their gum disease, 1 out of 60 flossed 7 times a week. So divide that in your calculator. 1 divided by 60. And we'll see what we get. I'm getting 0.0166666 forever. Now they want percent. Remember how to change to percent? You got to move the decimal 2 places. So it becomes 1.6666%. That's why there's 2 zeros in the percent symbol. I don't know if you've ever stayed up late at night wondering, why are there 2 zeros in the percent symbol? Now, that's just what weird math teachers do. But I'm here to tell you, it's there to remind you to move the decimal 2 places. It really means divide by 100. Percent is per 100. A century is 100 years. Percent's per 100. It's divide by 100. That's what it's telling you. When you divide by 100, you move the decimal 2 places. So that's why we move it 2 places. Okay, so here's our answer, but they want us to round to 1 decimal place. Now, you remember how rounding works? Let me bring it up here. 1.6666%. Now, you want to round to 1 place. So put a line right there. That's the first decimal place. If what's to the right of that line, this is 5 or more, which it is, then we go up 1.7%. So that's our answer, 1.7%, rounded to 1 decimal place. There we go, 1 out of 60. Number 3, it says 50 part-time students were asked how many courses they were taking this term. Here's the results. Determine the cumulative relative frequency for 2 classes. Okay, so number of courses 1, 2, relative frequency. So frequency, remember this means how many people. And relative, how are they coming up with that? That's the number of people divided by the total number. So they got this 0.6 because they took 30 people right here over 50 total on their calculator. They divided 30 divided by 50. You got to start with the number on the top, and they got 0.6 or 0.6. Same thing. That 0 on the front's optional. Doesn't matter. Okay, so well then let's do the same thing for this next one. That'd be 15 out of 50. If you divide that in your calculator, you get 0.3. So this is 0.3 or just 0.3, whatever, same thing. Cumulative. Cumulative means add them up, right? If you say something's accumulating, that means it's piling up, right? Cumulative means adding them up. So this one's just going to be 0.6, but this one is going to be these two added up, which is 0.9. See what I just did there? I added these up, got 0.9, and went there with it. You think, why didn't you do that in the first one? Well, there was only one in the list so far. You're adding down. When you're at the top number, there's nothing else to add. But when you get to the second number, you add those two. 0.9 is the adding up of the two relative frequencies. 0.9 then is our answer. Number 4. Same kind of thing for 3 siblings. So let's go through and do the relative frequencies. There's 200 people, so you know they got this one by taking 20 over 200 and got 0.1. And so we got to do the next one. We got to take 90 over 200. Use your calculator. I'm using mine right now. 90 divided by 200. I'm getting 0.45. Do the next one. 60 over 200. It's going to come out 0.3. And 0 out of 200, that's just 0, right? But do we really need to calculate that? 0 over 200, 0. All right, and they want the cumulative, so they want us to add up all the way to get this answer. So add up all these on your calculator. I'm getting 0.85 because this is 10, this is 30. If that helps you, you can just use your calculator. So there it is, 0.85. So 0.85 is the cumulative, the adding up of the relative frequencies up to 3. Up to 3, see? There we go. All right, number 5. Insurance companies are interested in the average health costs each year for their clients, so that they can determine the cost of health insurance. Match the vocabulary word with its corresponding example. Okay. So what are we doing on these questions? Well, they're going to have a list of words. You'll see, you can't see it on my PDF here, but you'll see it on when you're taking the actual quiz. Let's come on down. So all of the insurance company's clients. So what's that? All the options are going to be population, sample, parameter, statistic, variable, and data. Let me write those down. Well, all of the insurance company's clients. That's the population. That's everybody. The 400 clients in the study. So they did a study on 400 clients. Well, that's the sample. That's what statistics is all about. You take a small group of the whole group to learn something, right? Like when they poll before an election, right? It's an election year, and this is an election year, they're going to be polling like crazy. And so when they do that, they're going to take a small group of people, a sample, to learn something about what the whole United States might do, the population, right? That's what statistics, that's one of the main things statistics does. Next question. The average health care cost each year for all of the insurance company clients. That's the parameter. That's what you really want to know. And population goes with parameter. That's the real value that you're trying to figure out. The parameter. It's the value we want to know for the whole population. That's why I'm pointing to population. Whereas down here, let me show you something different down here. The average healthcare cost for the 400, well, that is just a statistic. That's the value for the sample. See, that connects with the sample. It's easy to remember. S with S, statistic with sample, and P with P, population with parameter. So in other words, it'd be like if I went, let's make the example, well, let's stay with the insurance. In the insurance case, they asked 400 people, and they found the average healthcare cost of those 400 people. That's statistic. They're doing that because they want to learn what the average might be for all their clients. That's the parameter. That's the value for the whole population that you're trying to learn about. Again, let's do the election. I think I found that's the easiest for students to understand. In the election year, they ask maybe 100, 200 people who they're going to vote for. And they say, well, on average, 51% are going to vote for this candidate. Well, they're doing that because they want to learn what the whole nation might do. Well, what the whole nation does is the parameter. That's the whole population. what percentage vote for a certain candidate. That's the parameter. Whereas statistic, that's just the value from your sample. S with S, P with P. Next one, the cost each year for healthcare. The cost each year. So cost, that's a variable. That's something that changes. And the list of 400 annual healthcare costs, the list of the 400 annual healthcare costs for the clients, well, that's just data. That's just information. So the variable is something that can change, the cost. Let's try another one. I think there's 3 of these. Let's do this next one here. So in this case, we're talking about a marriage counselor is interested in the proportion of the clients, I think there's an of missing there, of the clients she counsels that stay married. Okay. So all of the counselor's clients, she wants to know the proportion of the clients she counsels that stay married. So that's the population. Again, that's everybody. The 55 random that were chosen, that's just the sample. She just grabbed a small group. The proportion, in other words, the percentage, same thing basically, of all the counselors who stay married. Of all, that's from the population. So that's the parameter. That's the value of all from the population. And this one, the proportion of the 55, not of all, but of the 55. So that's just the statistic. That's just the value from the sample, right? A parameter and a statistic are both values. That's a value, value, and this is a value, but what's it from? The parameter is a value from the population, and the statistic is just a value from the 55, not from everybody, just from the sample. On down we go. To answer yes or no, that's a variable. It varies. Sometimes it's yes, sometimes it's no. The list of yes/no answers, that's the data. On down to number 7. A marketing company is interested in the proportion of people who will buy a particular product. All right, all people in the region, that's the population. The 380 that were randomly selected, that's the sample. It's looking familiar. The proportion or percentage of all, that is a parameter, right? Because it's a value from the population. And then the percentage or proportion of the 380. Of the 380, that's just a statistic. Why? Because it's a value from the sample, isn't it? S and S, sample statistic, P and P, population and parameter. The answer yes or no, that's a variable. The list of all the answers, that's just data. All right, there we go. So question 8. A restaurant owner is interested in the proportion of his customers who order dessert. He looks at 65 randomly selected receipts. Match the vocabulary words. So it's another one of these, right? All customers who came to the restaurant. That's his population. The 65, those 65 patrons, customers, that's the sample. That's a small group. The proportion, the percentage of all, that's going to be a parameter. And then this one, the proportion, the percentage of the 65. That's not of all, but just of the 65. That's a statistic. You see what's going on there again? The parameter comes from the population. It's a value. Parameter is a value from the population. A statistic is a value from the sample. The answer yes, no is a variable. And the list is data. All right. We've had enough of those, I think. Question 9. Which of the following are reasons that a sampling technique may not be scientific? Which ones of these are problems? It's a self-selected sample. Yeah, that's a problem. You can't have a sample where people self-select. If you say, okay, I want to figure out on average how many people are good at math on campus. Who wants to be in this study? Well, if you just let them volunteer, probably people better at math are going to be willing to volunteer. See what I'm saying? You can't really do a statistical study that's self-selected. If I just said, I want to find out who loves math, who wants to be in my study of, I'm going to pick 100 people, who wants to be in, people that like math better are going to be in there. You're not going to get the truth about what percentage of the campus really like math. You're going to get baloney if you do a self-selected study. That'll wreck it. That's not scientific. How about the next one? The sample stat is not exactly equal to the parameter. Does the statistic have to equal the parameter? No, just like up here, right? Or just like when I do a poll, and I say, what percentage you're going to vote for Trump in the election? Whatever X percent. If it comes out 51% and in the reality it was 49% and they're not the same, that doesn't mean it's not scientific. Just because those didn't come out, they're not going to come out exactly the same. That could still be a very good scientific study. What your sample says is not going to be exactly the same as what really happens. Hopefully it'll be close, but it doesn't have to be exactly the same to be scientific. The wording of a survey question. Yeah, that can make it, if you have bad wording, if you say, you're not going to vote for Trump, are you? Then that's obviously you're going to influence the people and get bad data. The sample is not representative. Yeah. See, I'm just going to ask the rich people who they're voting for. You're not going to get the truth. That can wreck a sample. The sample size, well, yeah, I'm just going to ask my family, or I'm just going to ask 3 people. Yeah, no, that can wreck it. Yeah. Those are all reasons. Everything except this one are reasons that can wreck a sample. The fact that the stat and the parameter, right, those are the values you get, like 51% in our sample, but really it's only 49. That doesn't matter. Number 10. Identify the data. Quantitative. Okay, so what are these? Well, let's look at the example. Number of students enrolled at a college. That's going to be a number. Now, can that be 200.7? You can't have 0.7 of a person, can you? It's got to be 201 or 200 or 212 or whatever, right? Or in our college, 30,512. No, maybe too many. I don't know. Whatever. So it can't. It's quantitative. Quantitative means numbers, and if it's discrete or continuous, let me explain. Discrete, it's limited in some way. Continuous can be any value. Can this be any value? No, it's you can't be 200.7. So this is discrete, quantitative discrete, because it's limited. It can't be a decimal, for example. It can't be half a person or 0.7 of a person. If the numbers are limited anyway, we call that discrete. If they're continuous, then they can be any value. Let's go down to number 11. Favorite baseball team. Is that my favorite baseball team? It's 7. No, it's not a number, huh? It's not a number. So then it's qualitative. That means it's qualitative. It's a quality. It's not a number. It's not quantitative, right? Quantitative is a number. All right. Number 12. Amount of body fat. Can that be 2.317 grams? Yeah. Can be any number, can't it? That's continuous. Quantitative, it's a number for sure. Continuous. All right. Number 13. A smartphone manufacturer wants to determine something. Okay. So to figure this one out, let's see. They're going to give us again some words about some different options. The manufacturer asks 100 of her friends who have the phone if she can borrow their phone. So she's just asking her friends. What kind of sampling is that? That's convenience, right? You're just doing what's easy, and you're not going to get good data. If you just ask your friends, you're going to get people like you. You're not going to really find out the true average of all people. Next one. The manufacturer tests 20 smartphones from each of its 5 equally sized distributors. 20 from each of its 5. That's stratified. That's a good idea because you're breaking it into strata. Strata are different groups. And so there were 5 distributed. 5, so they said, you know what we'll do? We're going to test 20 by getting 20 from each of our 5 groups. So that's stratified sampling. That's a good kind of sampling. That way you can find out the average better. That's how they do polling. They do stratified sampling. They make who they ask about election. They make sure there's however many of each racial group and men and women and people that are old and young. If half of America is, or let's say 30% of America is over 60, then they make sure 30% of their sample is over 60. Right? That's called stratified sampling. They make sure they match up the percentages in their sample with the reality. And that's what they did here. Next one. 3 small communities that have dry, moderate, and humid climates. Every smartphone from each of these 3 communities is tested. So that's cluster. So when they do that, that's cluster sampling. Because they grabbed every smartphone from these 3. So they just find 3 groups and then grab them all. That's called, they're in 3 clusters. When you grab all in a couple groups, that's cluster sampling. Next kind, let's see, what do we got here? Manufacturer test every thousandth. Every thousandth. That's systematic. They have a system. So every thousandth phone that comes in, they sample. Last one here. Manufacturer uses a computer to randomly select 150. That's simple random. They just say, let's just do it random. So these are different ways to sample, right? If you want to figure out the average battery time. I should have read that in the beginning. We're trying to figure out the average battery time. What's the best way to do it? Just ask all your friends. Well, maybe all your friends don't use their cell phones much or use it a ton, so that's not a good way to go. Stratified is a good way because you're breaking into groups. Cluster can be good. Systematic and random can be good. There's different ways of getting your sample. Let's try number 14. That'll be our last one. Number 14. Determine whether the following is an example of sampling error or a non-sampling error. A sociologist surveyed 300 people about their level of anxiety on a scale of 1 to 100. Unfortunately, the person inputting the data into the computer accidentally transposed 6 of the numbers, causing errors. Is that a sampling error? No, that's a non-sampling error. A sampling error is when you take a bad sample. Let's do this. When you use a bad sampling method, right? Like I said earlier, you only ask rich people who they're going to vote for. Rich people, who they're going to vote for. If you just go out and say, I'm just going to ask rich people who they're going to vote for. So go down to some really expensive restaurant or a rich country club and just ask the people, who are you going to vote for in the next election? Well, that would be a sampling error. This would be a sampling error when you have a bad plan for your sample. Why is that a bad plan? Well, because if you really want to know the truth of what's going to happen when the whole nation votes in November, then that's not a good way to get to the truth. Right? That's not at all a good way to get to the truth. That's a bad sampling method. You're just going to get what the rich people think. That's not going to be the same as the whole of America. That's a sampling error. You picked a bad sample. Don't just ask rich people. Don't just ask poor people either. Got to have a mix. So that's not what happened here. Here they just messed up the numbers. That's an error, but it's not a sampling error. So there we go. There is your first quiz. So you have to enter all those answers. Then it'll grade them all. Remember, you can do this thing again and again, but you have to do the whole thing every time. I know it's painful, but that helps you know really how ready you are for the exam, because that's how exams work. You got to do the whole thing on an exam. You can't check each question like homework. So there we go.